In this objective, we are asked to identify how many solutions there are to a system of two linear equations, both graphically and algebraically, or in other words, by drawing a graph or just looking at the equations or doing something with the equations themselves. When we talk about solutions to a system of linear equations, we are talking about intersection points. So in the first problem, problem type 1, where we are asked to sketch a pair of lines whose system of equations has exactly one solution, let's draw some x and y axes. And we want a pair of lines, so that's two lines. Any two lines will do, as long as they intersect somewhere. And because they're straight lines, they should intersect in only one place. So again, a solution is synonymous when we're talking about systems of equations. A solution is synonymous to an intersection point. So if we have exactly one solution, we have exactly one intersection point. Let's look at sketching a pair of lines whose system of equations has no solutions. Here we would need two lines that never intersect. So I'll draw my axes, x and y, and my lines. You'll notice I've drawn two parallel lines. Because they're parallel, they will never intersect, and therefore they have no solutions. Let's look at the third one. Sketch a pair of lines whose system of equations has infinitely many solutions. Again, solutions should bring to mind intersection points. So for this one, draw my x and y axes. I'm going to need two lines that have infinitely many intersection points. Would you agree that if the two lines are identical to each other, well, that was awful. Let's try again. I am challenged with drawing straight lines anyway, but especially if I'm trying to do it with a mouse on a computer. What I'm trying to go for here is two lines that are exactly one on top of the other. You can see I have a red line and a blue line, and one sits exactly on top of the other, so they have an infinite number of places where they touch. In other words, they have an infinite number of intersection points, and therefore we say they have infinitely many solutions. In problem type 2, we are asked to be able to tell algebraically that a system of equations has exactly one solution. Well, let's think about that. Just a little bit ago, we said that if the two lines intersect, like here, if the two lines intersect, then they have one solution. So what we would, well, let's actually, before we go on, if the two lines are parallel, they have no solutions. So what makes the difference between parallel and intersecting? Well, let's consider the slope of the two lines. If two lines have exactly one solution, then they have to have different slopes. Because if they have the same slope, they're going to run parallel to one another or be one on top of the other. So all we need algebraically is to be able to solve for y equals, put our lines in a y equals mx plus b form, and having done that, compare the slope of each of the two lines. So for example, if we have two lines, let's say y equals 2x plus 1, or y equals 3x. And it wouldn't matter what our y-intercept is on these, because the slope for these two lines is different. So how can we tell algebraically that a system of equations has exactly one solution? Well, there are a number of correct answers, but one answer to this is that the two lines have different slopes. if the two lines have different slopes, then they will intersect somewhere. Alternatively, how can you tell algebraically that a system of equations has no solutions? Well, again, if those two lines have the same slope, then they will either have no solutions or infinitely many solutions. Let's look back at our previous examples. Here we have no solutions, and we have two different lines with the same slope. You'll notice on these two lines, they have different places of intersection for, they have different y-intercepts. Whereas when we have infinitely many solutions, we have two lines with the same slope and also the same y-intercept. So, to go back to the question at hand, how can you tell algebraically that a system of equations has no solutions? Well, we would need two equations that have the same slope, and we don't want these two to intersect. Let me restate that. We want two equations that have the same slope, but we don't want the two equations to intercept the y-axis on the same place. So we would want same slope and different y-intercepts. So for example, we could have y equals 2x plus 1, y equals 2x minus 4. Same slope, different y-intercepts. This will produce parallel lines. Alternatively, how can you tell algebraically that a system of equations has infinitely many solutions? Again, there is more than one right answer here, but one way that you can tell is that the two lines have the same slope and the same y-intercept. That's supposed to say same. Let's fix it. So for example, y equals 3x plus 1 and 2y equals 6x plus 2. At first glance, these two equations don't appear to be identical, but because the second one has a common factor of 2 throughout, we could divide everything on both sides by 2, and we would end up with an equation that was identical to the first. So really, the two equations have the same slope and the same y-intercept.